Section 8.7, L'Hopital's rule. L'Hopital was a French mathematician, and he is credited with writing the first textbook on differential calculus back in almost 1700, a little bit before then. And one of his great discoveries was this L'Hopital's rule, which helps us solve limits in a more easy, a little easier fashion than what we've been doing. Remember in chapter 1 when we would solve limits by either factoring method. Another method we used was multiplying by the conjugate to get around substitution, where we ended up with 0 in the denominator. We had to come up with other algebraic techniques to do that. Well, what L'Hopital's rule states is the theorem says that under certain conditions, the limit of the quotient f of x divided by g of x is determined by the limit of the quotient of the derivatives. Well, that's interesting. So what you'll notice here is it has the layout for it. So the limit as x approaches c of f of x divided by g of x is equal to the limit of x as it approaches c of f prime of x divided by g prime of x. Well, this is interesting. The only way that I can apply this is if indeed the limit starts out as a 0 over 0 or infinity over infinity condition. So under certain conditions, and those are the conditions that we are looking for. So these are the hypotheses of our statement, the if statement. If this is true, then we can move into showing the derivative. So steps for using L'Hopital's rule, you'll notice it here. Test both the numerator and denominator, and let's see if it is meeting one of these two conditions. If the rule applies, then we can find the derivative of each the numerator and the denominator. And then what we'll do there is once we get that built, we'll evaluate the limit as x approaches c on these new functions that we did the derivative of. So the limit as x approaches -1. Well, if I just plug in -1 like we typically would do to solve a limit, I'd have 2 times -1 squared minus 2 divided by -1 plus 1, and we can all see how this is going to be 0 over 0. Well, that meets the criteria for L'Hopital, which means that I can go ahead and kind of invoke the L'Hopital rule and say that, well, then L'Hopital, sometimes you'll note that by just going LH, showing the reader that you are going to use L'Hopital's rule here as x approaches -1, derivative of the top. Here we are doing f prime, so I would have 4x on top. Derivative of the bottom would simply be 1. Now let's try and plug in -1. Use substitution. That's how you typically solve for a limit. 4 times -1 and 1 on the bottom makes this limit -4. L'Hopital's rule. Quite nice. Move on to B. This one I noticed the limit is as x approaches infinity. So as x approaches infinity, we also have learned earlier, haven't we? When it approaches infinity, we're kind of looking at what's the end behavior, what's happening as x heads to positive infinity. Well, we know if the degrees of the numerator and denominator match, we can just compare the coefficients, and this should end up being 5/2. Well, let's see if L'Hopital's rule follows suit and gives us that. So, first thing we got to check is, does it go to 0 over 0, or is it infinity over infinity, positive, negative? It doesn't really matter. So take infinity, plug it in. 5 times something large squared will be something large. 2 times something large squared will also be something large. So indeed, this is meeting the criteria. It's infinity over infinity. Let's try and use L'Hopital's rule then. Using L'Hopital, he says take the derivative of the top, so the limit as x heads to infinity. The derivative of the top looks like 10x, doesn't it? Derivative of the bottom is 4x. If I stopped now and tried to do substitution, I would put infinity in, and I would have infinity over infinity, which means, well, you know what? It's still meeting L'Hopital's condition. Let's do another L'Hopital. Yes, indeed, we can chain off and continue to do more L'Hopital's rules. So the limit as x heads to infinity, take the derivative of this. Well, that's just 10, and the bottom would be 4. The derivative of 4x is 4. Notice now we get numbers. Reduce it, and we get the limit of 5/2. Probably a little bit of overkill for this particular problem because we knew how it behaved before we even started, looked at the coefficients, and knew the limit should be 5/2. But it also reinforces that L'Hopital's rule did indeed work here. Okay, how about C? We're heading to 0. So what we have to do is substitute 0 in. Let's see what the limit looks like. If I put 0 in, I get e to the 0 minus 1 over 0. So I'm definitely dividing by 0. E to the 0 is 1. 1 minus 1 is 0. Okay, this will work for L'Hopital. So let's try it. Derivative. Derivative of the top. It's good to keep writing that limit over and over because that indeed is what we're trying to evaluate. The limit as x heads to 0. Well, e to the 2x is e to the 2x. Chain rule would give us a 2 as well. Derivative of the bottom is simply 1. Now let's try substitution. Putting 0 in, I'd have 2e to the 2 times 0 over 1, which makes this 2 e to the 0, which is 1, because that was a 0 there, and then answer turns out to be 2. The limit is 2. I'm sure that you're kind of getting the flavor of these. Let's just do a couple more, and then I think you're probably good to go on your own and get the worksheet for homework and work on that. If I plug in infinity, the natural log of something very large, of a big number, over a large number here, which is infinity, well, the natural log of something big is also going to be big. Think of this, you know, we've got the base of e. E to something makes big. Well, e to the infinity will make big. And then on the bottom, I'm going to have infinity. Does it meet the criteria for L'Hopital? Yes, it does. So we can invoke the L'Hopital rule and the limit as x approaches infinity. Now, derivative of natural log, you remember, is 1 over x. The bottom is just 1, isn't it? Derivative of x is 1. Let's try plugging in infinity. So I've got 1 over infinity, or 1 over large, makes this thing go to 0. The limit would be 0. Letter E. There's just some funky, functions. I thought it would be good for you to see a variety of functions here. So if we take negative infinity, plug it in, this will be something very large, won't it? It'll be a positive infinity. So we got positive large. On the bottom, I'm going to have e to the negative of negative infinity. Well, that is going to look like, so we've got large on the top. Here, this will turn out to be e to the positive infinity, but that too is going to just create us a very large number, so we get infinity over infinity. So evaluating that to determine if we can use L'Hopital was interesting. L'Hopital, okay, so the limit as x heads to negative infinity. Derivative of the top, nice simple one, 2x. Derivative of the bottom, well, e is itself, and then chain rule, derivative of negative x will be negative 1. I'm going to put that negative out front. Let's try plugging in negative infinity. I'll have negative infinity on top. What happens to our bottom? Well, that will look like e to the negative, but that's, so I've got negative infinity over e to the large, which will be large. So it appears to me that we're still sitting with infinity over infinity. Let's try to do another L'Hopital. So the next L'Hopi will be limit as x heads to negative infinity. The derivative of the top is 2. Derivative of the bottom would be e to the negative x. And then the negative will come down, making this a positive 1 by chain rule. So this will turn out to be looking just like that. All right, so we get 2 times e, oops, how about that's under, 2e to the negative, negative makes this positive infinity. So now I get 2 divided by something very, very large. That's going to make this go to 0. So that time it took 2 L'Hopitals to figure that out. One last one. Let's do F, and then I think you can be on your own. F is interesting because we've done this before, right? This is one of our memorization limits that we did. It was a special one. The limit as x heads to 0 of sine x over x we know to be 1. Let's see if we can prove that it is indeed the case. So if I plug in 0, I get the sine of 0 over 0. But the sine of 0 is 0, so I get 0 over 0. Not very helpful, but it tells me that I can use L'Hopital. So L'Hopital maybe can help us solve this problem. The limit as x heads to 0. Well, I would have derivative of sine is cosine x. Derivative of x is 1. Try substituting now, evaluate the limit at 0. Cosine of 0. And then we'd have 1 on the bottom. Cosine of 0 is 1. 1 over 1 is 1. Ooh, that's cool. That's what we thought it should be. It's one of those ones we memorized and we just proved it out using L'Hopital's rule. Enough of notes. I don't want to make them too long. Here is the worksheet I would like you to work on and have done for tomorrow. It should just be front-sided only. Give it a try.